Dear students, welcome to our class on Indian monsoons 2, variability of rainfall. In the first class of Indian monsoons 1, we tried to understand what is the mechanism of Indian monsoon. The mechanism of Indian monsoon is basically the differential heating of land and water. Differential heating of land and water. So that is the basic mechanism. For the benefit of our beloved students, a bit may come in the JRF SRF. What is the mechanism of Indian monsoon? A, B, C, D, they may give it in that differential heating of land and water bodies. Okay, so land means Asia or otherwise India, peninsular India. Water bodies means eastern side Bay of Bengal, western side Arabian Sea, southern side Indian Ocean. That's what. So in this class, we try to understand what are the reasons for the variability. As far as variabilities are concerned, interannual variability is there between the years. Intra-seasonal, within the season, that means southwest monsoon season, June to September, within the season. Diurnal, it's very interesting, even day and night. So millennium, which is something related to high-powered simulation models and couplings of several models. Millennium, that's what we are going to discuss in this class. Now, once again, for your academic interest, the differential heating of land and water bodies or oceans is the basic mechanism. That's what we understood in the Indian monsoons 1. Now, variability. Why? What are the reasons? What are the causes for the variability of Indian monsoon? See, in this class, we just, variability is inevitable. Why it is inevitable? Because a differential heating of land and oceans should be there. Interannually, that means in between 2 years, insulation may be almost constant. So, in addition, there are two driving forces actually. For the Indian monsoon, there are two driving forces. Number one, sensible heat released in the Indian subcontinent, particularly in the southern part of peninsular India. Sensible heat means, the energy that is utilized in heating the air. Sensible heat. That is for number one. Number two, from the oceans, once the monsoon winds come, southwest monsoon, warm and humid. Warm. So, that warm, humid winds from predominantly south and western direction, when they enter into the Indian subcontinent, what happens are condensational heating. That means in the process of condensation, heat is released. That's what we call it as the latent heat also. So, latent heat of condensation of the large, warm, humid air masses. Before that, the sensible heat. These two. So, interannually insulation may be same, but the latent heat and the sensible heat play an important role with reference to variability. This question would come. SRF, even that in the writing parts and everything also. So that's why we try to understand in a very simple way, exclusively useful for we the agrometeorologists, not the whole of climatology. Okay, climatology of the variability of monsoon, enormous monographs, good number of books were there. Say for the last 400 years, good number of theories. Halley, almost 300 years, not almost, slightly over 300 years, Halley proposed it. So, from then onwards, so much of them, but we try to understand in this class, which is pertinent to only agricultural meteorology. Now, here, see, the Indian monsoon is also known as the part of the Asian monsoon because it extends from 25 degrees south latitude, 25 degrees south to 35 degrees north latitude. Okay, 25 degrees south, 35 degrees. In addition, 30 degrees west and 170 degrees east of longitudes. So eastern, okay, up to Indian. So this much Asia is covered. However, we confine ourselves to India. So now, see, the Indian subcontinent lies near the center of the Asian monsoon. Okay, surrounded by ocean three sides. Eastern side, Bay of Bengal. Western side, Arabian Sea. Southern side, Indian Ocean. And, okay, land mass, wonderful land mass. Western Ghats, Eastern Ghats, Himalayas, like this. Now, although the Indian monsoon comes with a reassuring regularity, Indian monsoons arrives with a reassuring regularity. It exhibits, even though it comes with reassuring regularity, it onsets with withdrawal is imminent. No, but however, it exhibits a wide range of variability on the spatial, temporal, interseasonal, interannual, millennium, and diurnal. So, Indian monsoons with a reassuring regularity, it is a phenomenon happening for hundreds and thousands of years. But variability is there. Now, the monsoon rainfall also exhibits some diurnal characteristics over the tropical region. That's what we discussed at the penultimate. After 4 or 5 minutes, we discuss that point. Now, so different temporal scales of Indian monsoon. Different temporal scales. Number one, the summer monsoon from June to September, even though October 15th also, up to that point also, even though we get there September 15th, June to September, okay? So, some Indian summer monsoon rainfall, ISMR, we call it as in the climatological terms. It is mainly driven by, Indian monsoon is mainly driven by two heat sources. Number one, that's what I told half minute back, sensible heat of Asian landmass and condensational heating, that is the latent heat within the troposphere over the Asian plateau. So, sensible heat of the landmass, latent heat of the condensational cooling of the warm and moist winds. That's what we call latent heat. These are the two heating sources. But these sensible and latent heat mechanisms contribute to the land-sea temperature and pressure differences. See, both these latent heat and before that sensible heat, these two causes land-sea temperature differences and pressure differences, and that ultimately drives the summer monsoon, which drives the Indian monsoon. Number one, two heat sources: sensible heat over the land mass, latent heat from the condensational cooling of the air masses entering in from predominantly from southwest direction during June and July. These two. Now, these two heat sources, in addition, what these two heat sources cause differences in the heating of land and sea and also pressure. So, differential heating of land and sea and pressure, they drive the Indian monsoon. This is the basic, reason for the variability. This is the basic reason for the variability. Now, the most important scale of monsoon variability is the interannual and intraseasonal. In between the years, variability in the monsoon is there. Even though, of course, in between the years, monsoon variability is less. But intraseasonal, within the southwest monsoon season of June to September, the spatial and temporal changes of rainfall occurring are very high quotient of variation. That's what we discussed in half minute from now. Now, see, Indian summer monsoon exhibits, that is the Kharif season we call it. Indian summer monsoon exhibits large spatial variability with regions of high rainfall. Where? Western Ghats. Okay? Where the coefficient of variation of rainfall quantity is less. I repeat once again. Heavy rainfall or huge quantity amount of rainfall, occurs in the Western Ghats area, okay, which is having lowest possible coefficient of variation quantity wise. Now, least amount of rainfall occurs in the northwestern India, where the coefficient of variation is very high. This bit will come. Coefficient of variation is high for lowest rainfall receiving areas in the northwestern sides of India. Lowest possible coefficient of rainfall variability, where heavy rainfall occurs in the western Ghats, okay, and to some extent for northeast also, to some extent, but western Ghats, to some extent in the northeast, where coefficient of variation is less. Now, see, the daily monsoon rainfall shows highest variability. The daily monsoon rainfall shows the highest variability of 60 to 70% during the onset, 4th of June, sometimes even 25th of May also. In my experience of 42 years of in the 42 years of my experience in this field, 25th May also rainfall monsoon set occurred as late as 6th or 7th of July. I saw 6th or 7th of July. Okay, that means so initial onset coefficient of variability for onset we standard would take 4th of June. Some books 5th of June we call it, but earlier or later coefficient of variation on the onset is 60 to 70%. Similarly, coefficient of variation of rainfall in the withdrawal in the month of September, okay, is 50 to 60%. Onset 60 to 70, 50 to 60% withdrawal variation. That much is there. But from July and August months, where during which period heavy rainfall occurs across the Indian subcontinent, the coefficient of variation is 25 to 35%, or in some books you will find 35 to 40%. 35 to 40% latest analysis, you please take. So July and August coefficient of variability of rainfall is 35 to 40%. Now, see, interannual variability. Now we try to discuss interannual in 1 minute, intraseasonal 1 minute, diurnal half minute, millennium half minute. Only that much is there. Now, interannual variability. See, if the rainfall that occurred in the last year is good and it's not occurring in the next year, agriculture will affect. So, the basis of what I told 2 minutes back, interannual insulation is constant, almost constant, negligible change is there. So, the heat sources of these two, that's what I told. Sensible heat for the land, latent heat of condensational cooling play an important role in the interannual variability. This bit will come. Now, see, interannual variation of Indian summer monsoon is not very large over 136 years. Interannual variability is not that much. During the last 136 years, analysis of the data says maybe 1125, 1175, something like that, 1050, like this it goes on, we go on getting it. Now, see, if the analysis of 136 years told that, it revealed that 17.6%, that is out of 136 years, 24 years are drought, 19 years are excess rainfall. 24 years are drought, that means 17.6%, and flood years are 19, accounting for 13.9 years. This is the interannual, in between the years. 136 years data analysis is like this. Now, intraseasonal. This is very interesting, intraseasonal. So, rainfall occurs on 4th of June, excellent. At least 10th of June, good. But after that, we have to go for contingency plan as far as agriculture is concerned. So, heavy rainfall occurs in the western Ghats. No rainfall occurs in the northeastern side. What is the problem? This is a serious problem. So, interseasonal variation of interseasonal variability of rainfall, interseasonal. Now, see, long breaks in critical growth stages of crop play a negative role for the crops. A break situation of monsoon rainfall is one in which the surface, this bit will come. Break situation in the monsoon or lull in the monsoon, we call it. When See, this is the word you should write. The surface trough. The surface trough, okay, that's what we also call monsoon trough, is located close to the foothills of Himalaya. The surface trough goes close to the foothills of Himalayas, and easterlies disappear from sea level. Easterlies, okay, these are the two reasons. Or at least one reason, if you write, you get 1 out of 1 mark. So, monsoon trough going to the foothills of Himalayas causes break in the monsoon. Now, there is a change in oscillation. Oscillation means, 3 to 7 days oscillations are there. It is because of the monsoon trough. Monsoon trough goes to Himalayas, foothills of Himalayas, or easterlies disappear. Okay, 3 to 7 days oscillation, they may revert back. However, 10 to 20 days oscillations are there. These are associated with westward moving of the waves generated over the warm Bay of Bengal. Bay of Bengal becomes warm, westward waves, okay, moving, westward waves moving up from the warm Bay of Bengal. Third one, 30 to 60 days. Nobody can do anything. 30 to 60 days oscillations are associated with large scale coupled patterns. See, say large scale. That's what we discuss in the next class. That is monsoon. See, now here, so diurnal variability and mean variability in half minute. I will tell. Diurnal variability of the rainfall. The analysis of the data, particularly from the satellite data, says that over Indian subcontinent, the rain occurs in the afternoons. This is number one. Rain occurring in the morning has high intensity and long duration. Once again, I repeat it. Diurnal. If you take in a 24-hour period, most of the rain occurs in the afternoon. Number 1 point. 2 point. The rainfall that starts in the morning has high intensity for long duration. Now, so if we go to millennium variability, see how we can get it. We have the records of maybe 250 to 300 or 400 years. Prior to that millennium, how? Yes. Take this from the science, take this from the science, that there are proxy indicators of climate. There are proxy indicators of climate. For example, if you take perennial trees which are in the forest, there are tree rings. They are the good indicators of whether a year is a monsoon, good monsoon year or otherwise. Similarly, innumerable climate sensitive signatures are available in the Asia monsoon area. So from them, if we take it, I am not interested to use the word thousands of years, hundreds of years, or you can say yes, hundreds and hundreds of years also we can use it. The monsoon is occurring with a reassuring regularity. Number one, there is a variability, spatial and temporal, annually, intraseasonally, even diurnally also. Now, these are the things, these are the scientific findings of the research of India Meteorological Department, and these are all the things that I have taken from their monograph. Thank you for your patience here.